So this is our calculus video. First we're going to talk about the estimating gradients and how this relates to calculus in the first place. So when we're estimating gradients, we have some function which we draw as a curve. Then when we're finding the gradient or estimating, we'll draw a tangent at a point on the curve or on the function, and we will find the gradient of the tangent. Okay, and this is an estimate of the gradient. So here is a function, here's a curve I've drawn. Let's say we wanted to find the gradient at that point. We would draw a tangent. To find the gradient of the tangent, we find the rise and the run, and then that is an estimate of the gradient at that point. Okay, so for calculus it's similar. We take a function, then instead of drawing a tangent at a point, we're going to differentiate. Okay, so we differentiate to find the gradient of the function. Okay, then we plug in the x value. So where we're trying to find the gradient, we plug in that x value, and this will give us the exact gradient at that point on the curve, on the function. Okay, so this is how calculus links to estimating gradients, which we looked at before. In this video, we're going to look at the process of taking a function and differentiating it. So how does that work? How do we do that? Why, when we differentiate, find the exact point, why that works, we're not going to go into too much. Well, we're not going into it at all. Some very clever people, namely Newton and Leibniz, they were the people who came up with calculus in the first instance. And it took, it was several hundred years ago, and we're not going to go into why, but if you want to take that further, then do A-level maths, or go further than that. Okay, so we're also going to look at notation quickly. We've looked at a particular notation in class. We're going to look at some other notations that might come up. So a function could be written as f of x. It could be written as y is equal to. So let's say a function y is equal to x cubed plus 2x. We also know function notation fx equals x cubed plus 2x. We could also have a different variable like a is equal to r cubed plus 2r. So these are functions. Now when we differentiate, the notation for that, if we have f of x, then the derivative is f dashed of x. Okay, this is the this side here, this is the gradient function. Okay, so this is differentiating. So when we differentiate fx, we get f dashed of x, and this will tell us the gradient function. dy dx, if we differentiate y, we get dy dx. If we differentiate a in this bottom one, the gradient function can be written as dA dr. You can see how when we have y equals x cubed plus 2x, the derivative is dy dx. When we have a equals r cubed plus 2r, the derivative is dA dr. Now Max Acas asked the question, why is it dy dx? Well, if you remember from the other video, we said that the gradient could be written as the change in y divided by the change in x. This is the rise and the run. So it kind of links to this idea. So dy dx is similar to the change in y divided by the change in x. If you know how to differentiate already because you remember, maybe you can write down what the answers to the derivatives are. Okay, now we're going to do some examples quickly on the how to differentiate. Then we're going to take a couple of exam papers, past paper questions, and have a look at those in context. So this is a quick overview on how differentiation, how calculus links to estimating gradients by drawing tangents. The important thing is finding the gradient function. The gradient function is like a formula that tells us the gradient at any point on the curve, rather than having to draw tangents all the time. Okay, let's carry on. Okay, so the how to differentiate. So the basic instruction is multiply by the power, and reduce the power by 1. So let's look at an example here. If y is equal to 4x cubed plus 7 times x to the minus 3. Okay, so when we differentiate, we get dy dx. This is the gradient function, the formula for telling us the gradient. So we times by the old power. So the first term, we're going to do 3 times by 4. This gives us 12, and reduce the power by 1. Then we're going to do the same thing to the second term. So 7 times by minus 3 is minus 21, and then reduce the power by 1. Okay, so that's how to differentiate. We do each term separately. This thing that we've just written is the gradient function. It tells us how to find the gradient. Let's do another one with the different notation. The function is equal to 3x. Okay, so if you know what this should be, maybe pause the video and answer it yourself. Otherwise, the derivative we write as f dashed of x now. Okay, so we can actually write 3x as 3x to the power of 1. I think that's what's written on your sheet anyway. If we times by the power, we get 1 times by 3. And then if we reduce the power by 1, we get x to the power of 0. Now we all know that x to the power of 0 is 1. Anything to the power of 0 is 1, so this is just 1 times 3 times 1, which is just 3. So when you differentiate 3x, you get 3. And this is kind of going to be a rule of thumb. We're going to write some rules of thumb up here. And this is already written on your sheet, I think. The derivative of ax is a. So for example, the derivative of 3x is 3. Okay? So anytime you have a number times x, the derivative is that number. So we've got another one now. Y is equal to 2x cubed plus 5. Okay, so if we look at dy dx, when we differentiate 2x cubed, maybe pause the video and see if you can do it yourself. So we should get 6x squared by timesing by the power and reducing the power by 1. When we differentiate 5, we have to think a bit carefully about this. So I'm going to rewrite 2x cubed plus 5 as 2x cubed plus 5 times x to the power of 0. Now, x to the power of 0 is 1, so this makes sense because it's just really writing it as 5 times 1, which is 5. So I haven't changed the function we're looking at here. But this allows us now to differentiate 5 on its own, because if we differentiate 5x to the 0, we're going to times by the power. Okay? Timesing by the power gives us 0 times by 5x to the power of something, but it doesn't matter, because 0 times 5 is 0. So when we differentiate 5 on its own, we just get 0. So the derivative of that function 2x cubed plus 5 is just 6x squared plus 0, which is 6x squared. So another rule of thumb is the derivative of a number is 0. For example, 5, the derivative is 0. Okay, let's look at another question now. If we have y is equal to 3x to the power of minus 4 plus 5 over x plus 7, well, what is the derivative of this? Maybe pause the video and work it out yourself. For the first term there, we get minus 4 times 3, which is minus 12, x to the minus 3, x to the minus 5, sorry, reduce the power by 1. We're not quite sure how to differentiate 5 over x yet, but we know when we differentiate 7, we're just differentiating a number, so we get 0. So when we have to differentiate a fraction like this, fractional terms, we have to change them to index terms. So terms with indices. So 5 over x is the same as 5 times x to the minus 1 plus 7. If you're not sure about this, then you should really go back and look at the indices videos to try and remember how to do negative indices and how they turn into fractions. Writing the term like this now allows us to differentiate because we times by the power, so minus 1 times 5 is minus 5, and reduce the power by 1. Okay, so now this is the derivative. So another rule of thumb, if a term is in fractional form, change it to index form before you differentiate. So for example, 5 over x is 5x to the minus 1, which differentiates to be minus 5x to the minus 2. 3 divided by x squared is the same as 3x to the power of minus 2. Differentiate this and you get minus 6x to the minus 3. Times by the old power, reduce the power by 1. Okay, so let's look at a quick example which will feed into our exam questions coming up. So let's say we have the green function here, the third function down, y equals 2x cubed plus 5, and we want to find what is the gradient when x equals 2, and what about when x equals negative 1. Okay, so if we're trying to find the gradient when x is 2, we're going to say, well, we know dy dx is 6x squared. Okay, this is the gradient function, this is an instruction for how to find the gradient, so we're going to take our x, we're going to square it and times it by 6. This will give us the gradient when x is 2. So this is 6 times 2 squared, 6 times 4, which is 24. So what is the gradient of the function when x equals minus 1? Well, we know what the gradient function is, it's 6x squared, so we put minus 1 into that, and we get 6 times minus 1 squared. Minus 1 squared is 1, 6 times 1 is 6. So the gradient when x equals minus 1 is 6. Okay, so this, I'm looking at the third function down. If you weren't sure where I was looking at the third function down. Let's do a quick example with the fourth function down. Or maybe not. we're going to leave it there, stop the video, and move on to some exam questions coming up.